Welcome to The Explainer. Okay, so June 16th. On the surface, it's just a normal day. You might grab a cup of coffee, check your email, just kind of go about your business. But secretly, actually, it is one of the greatest, weirdest, and most coincidental dates in all of math history. Seriously, today we're going on a bit of a detective story together. We're looking at a single date where, across completely different centuries and completely different countries, brilliant minds changed the very fabric of the world we live in right now. On this one incredible date, our journey travels across literally hundreds of years. We're going to use 7 specific mathematicians who were either born or who died right on June 16th, and they're going to act as our roadmap today. We'll meet them one by one, and by the end of this, you'll see exactly how their brilliant insights basically built the modern world. All right, let's just get right into it. Okay, let's dive right in with our first mystery. Have you ever actually wondered how we predict nature? I mean, really think about it for a second. How do we know with any certainty if it's going to pour rain tomorrow, or exactly how an object is going to fall through the sky? We totally take it for granted, but fundamentally it's just one massive calculation.
Well, the answer goes way back to June 16, 1888, and a guy named Alexander Friedmann.
So Alexander Friedmann used mathematics to model incredibly complex physical movements. During his life, he used math to compute the exact trajectory of falling objects, predicting how things move through the air, which is absolutely stunning precision. But here's the crazy part. He didn't stop there. He actually took a look up at the stars and applied those exact same rigorous mathematical principles to the cosmos. Friedmann was the very first person to prove the mathematical possibility that our universe is constantly expanding. It's a totally mind-bending concept and is actually deeply connected to the physics engines we rely on today in stuff like our video games and complex weather simulations.
So here's a massive takeaway for you. The math that predicts tomorrow's rain also proved the universe is expanding. It's just absolutely amazing to think that a single mathematical vision connected our everyday earthly weather to the entire cosmos.
Still on June 16th, obviously, but now we're going to jump way ahead to the turn of the 21st century. We're about to meet 2 incredible minds who incredibly shared the exact same death date.
But before we do, think about the device sitting in your pocket right now for a second. Have you ever wondered how your smartphone can calculate millions or even billions of things in a single second? How on earth does it process all those high-definition graphics, instant messages, and background apps without even missing a single beat?
The answer actually goes back to 2 pioneers who tackled early computing on completely different continents. We've got Herman Goldstine, who died on June 16, 2004, and Alessandro Faedo, who died on June 16, 2001.
The crucial point here is that our modern smartphones didn't just appear out of thin air, right? Goldstine helped develop the ENIAC in America. Now, this was a massive 30-ton electronic computer that could perform 333 calculations a second, which, hey, was absolutely revolutionary at the time, even though, honestly, your modern microwave could probably outsmart it today. Meanwhile, over in Europe, Fabricio championed computer science and built the very first computer in Italy. These massive, literally room-sized machines laid the physical groundwork for every single smartphone, tablet, and laptop we use today.
And this brilliantly illustrates our next point. Every video game you play started with a giant machine and a single line of math. There is a direct, undeniable line from those 30-ton mainframes straight to our sleek, handheld devices.
One date. So many stories, right? Let's keep going and rewind a little bit to the year 1915 to meet a mathematician whose work is quite literally in our ears every single day.
Have you ever wondered why your Spotify or Apple Music streams sound so crystal clear even when you're stuck on a really slow internet connection or maybe riding in a car through a tunnel? Like, how do we send so much rich audio data through the air so incredibly fast?
The answer for that one goes back to June 16, 1915, and a mathematician named John Tukey.
Let's see how his work literally builds our modern world. John Tukey introduced something called the Fast Fourier Transform, or FFT. In plain English, this is a brilliant math algorithm that takes incredibly complex data, like the rich, layered sound waves of your favorite song, and breaks it down to compress it into simple, manageable pieces. Because of this mathematical compression, our devices can stream flawless audio and crisp 4K video over the air without just constantly buffering. It really makes you stop and realize every song you have ever heard is secretly made of math.
Now let's seamlessly shift gears to another mystery we experience every single day. When you type a question into a search engine, how does the computer actually know exactly what you're looking for?
How does it logically filter through millions of web pages in a fraction of a second to give you the one right answer?
The answer to that spans across centuries, connecting two mathematical detectives, Ernst Schröder, who died on June 16, 1902, and Jacques Ozanam, who was born way back on June 16, 1640. Just think about that massive gap in time for a second.
So here's how these two vastly different centuries connect to our modern internet. Schröder was a pioneer in the algebra of logic and set theory. His work is quite literally the brain of our modern search engines, teaching machines how to logically sort, categorize, and intersect vast amounts of information. On the flip side, Ozanam was a pioneer of recreational mathematics. He wrote famous books on math puzzles and games back in the 1600s. While Schröder gave computers their logic, Ozanam's puzzle-solving framework is the very soul of how we write computer programming today.
It's just an incredible realization. The puzzles we play for fun are the very rules that teach computers how to think. Logic and play are truly just two sides of the exact same coin. All right, let's jump back in time one last time, zooming in on the year 1866. We've talked about the universe, computers, music, and search engines, but all of this brings up the ultimate foundational question. Why do the rules of math work exactly the same way every single time? Like, why can we trust the invisible code running our GPS maps, our banking apps, and even life-saving hospital equipment without it all just collapsing into total chaos? Well, the answer takes us right back to June 16, 1866, and a mathematician named James Pierpont. Pierpont was an absolute master of making sure things worked perfectly. He explored the incredibly strict conditions and rules of calculus. He basically dedicated his work to making sure that complex math functions are perfectly rigorous, meaning he proved the boundaries of exactly where the math holds strong and where it might eventually fail. And because mathematicians like Pierpont ensured this foundation is rock solid, our complex software and digital networks don't just unexpectedly crash when we need them the most. Every single person we met today, across totally different centuries and different countries, all essentially asked the exact same question. What is the pattern hiding inside the chaos? And because they asked that, our world today has GPS, streaming audio, global search engines, and the modern internet. But it kind of makes you wonder, right? As you look around at the chaotic data of our modern world today, what new patterns are just waiting for you to discover them? Thanks so much for joining me on this journey through math history.